Hello everyone, and welcome to the first video on my channel. Today we will be discussing space habitats. I will be explaining the potential benefits and challenges of building them, as well as the different types of space habitats there are. If that sounds interesting to you, stick around for the video and enjoy. And don't forget to hit the like button and subscribe, as it seriously helps out the channel. One of the key potential benefits of space habitats is that they could serve as a stepping stone for further exploration and settlement of our solar system. As humanity begins to venture beyond the confines of Earth, space habitats could provide a crucial waypoint, offering a safe and comfortable place for astronauts to rest and resupply before continuing on to other destinations. Space habitats could offer a unique environment for the development of new technologies and techniques that will be needed for long-term space travel, such as advanced life support systems and advanced propulsion systems. Additionally, space habitats could provide a valuable platform for scientific research. In a space habitat, researchers would be able to study the effects of long-term space travel on the human body, as well as conduct experiments in microgravity and other extreme environments. This could lead to important breakthroughs in fields such as medicine and materials science, with potential applications on Earth as well as in space. Space habitats could potentially provide a new source of valuable resources, such as rare minerals and metals that are difficult to access on Earth. In the future, space habitats could serve as mining platforms, allowing us to extract these resources and use them to support further space exploration and development. This could be particularly important as we begin to establish permanent settlements on other bodies in our solar system, such as the Moon or Mars. Lastly, these space habitats could also serve as a potential refuge in the event of a catastrophic event on Earth, such as a global war or a large asteroid impact. In the words of Carl Sagan, everything humanity thought of, said, did, and created, was on this pale blue dot, suspended in space. All it would take is one asteroid impact, or perhaps a CME from the Sun, to destroy it all. To many people, expanding humans beyond the planet Earth is imperative to the survival of the species. Building space habitats presents many potential challenges. One major challenge is the cost and technical difficulty of launching materials and equipment into space. This is a significant barrier to the construction of any type of space habitat, as the cost of launching even small amounts of material into orbit can be astronomical. Another challenge is the harsh environment of space itself. Space is a hostile environment, with extreme temperatures, high levels of radiation, and the lack of breathable air and gravity. This can make it difficult to design and build space habitats that can protect their inhabitants from these hazards. Additionally, the long-term effects of living in a microgravity environment on the human body are not fully understood. Prolonged exposure to microgravity can lead to a variety of negative health effects, such as loss of bone density and muscle atrophy. This means that building space habitats will require a thorough understanding of how to mitigate these effects and keep inhabitants healthy. Another challenge is the need for self-sufficiency. A space habitat will need to provide its inhabitants with all the resources they need to survive, such as food, water, and oxygen. This is a significant challenge, as a space habitat will be cut off from the rest of the world and will not be able to easily resupply from Earth. Finally, there are also psychological challenges to consider. Living in a small, enclosed space for extended periods of time can be difficult, and can lead to isolation, confinement, and other mental health issues. Designing space habitats that can support the psychological well-being of their inhabitants will be essential. Overall, building space habitats presents many challenges, from the technical and logistical to the psychological and health-related. Overcoming these challenges will require significant advances in technology, engineering, and our understanding of the human body and mind. There are many different types of space habitats that have been proposed or discussed by scientists, engineers, and space enthusiasts. Some of the most common types of space habitats include space stations. These are artificial structures that are designed to orbit the Earth or other celestial bodies, and are inhabited by humans or other organisms. Space stations are typically large and complex, and are used for a variety of purposes, including scientific research, military operations, and commercial activities. Habitat modules. These are smaller, self-contained units that are designed to be attached to a space station or other spacecraft. Habitat modules provide a comfortable living environment for humans and other organisms, and may include features such as air and water recycling systems, temperature control, and artificial gravity. Planetary bases. These are structures that are built on the surface of a planet or moon, and are intended to be inhabited by humans or other organisms. Planetary bases are typically large and complex, and may include a variety of different structures, such as living quarters, research facilities, and transportation systems. Space colonies. These are large, self-sustaining habitats that are designed to be located in space, away from the surface of a planet or moon. Space colonies are typically much larger than other types of space habitats, and may be home to tens of thousands or even millions of people. They may be located in orbit around a planet or other celestial body, or may be located in deep space. Asteroid habitats. These are structures that are built on or within asteroids, and are intended to be inhabited by humans or other organisms. Asteroid habitats may be used for a variety of purposes, including mining operations, scientific research, and space tourism. O'Neill cylinders are a type of space habitat that was proposed by Gerard K. O'Neill, a physicist and space entrepreneur. The concept of an O'Neill cylinder is based on the idea of creating large, self-sustaining habitats in space, away from the surface of a planet or moon. An O'Neill cylinder is a hypothetical structure that consists of two cylindrical shells, each with a radius of several kilometers and a length of several tens of kilometers. The two shells are connected by a number of spokes that provide structural support and allow for the movement of people and materials between the two cylinders. The interior of an O'Neill cylinder would be divided into several different environments, each with its own unique climate and conditions. For example, one section of the cylinder might be designed to mimic the conditions on Earth, with breathable air, temperate climate, and artificial gravity. Other sections of the cylinder might be designed to simulate other environments, such as the surface of Mars or the bottom of the ocean. The idea behind O'Neill cylinders is that they would provide a comfortable and sustainable living environment for humans, allowing us to expand our presence in space and potentially even establish colonies on other celestial bodies. However, the technical challenges associated with building such a structure are significant, and it is not clear if O'Neill cylinders will ever be built. One potential benefit of space habitats is that they could provide a new frontier for human expansion and exploration. This could help to advance our understanding of the universe and could also provide new opportunities for scientific research and discovery. Space habitats could also serve as a way to alleviate the problems of overpopulation and limited resources on Earth. By establishing communities in space, humanity could have more room to grow and could potentially access new sources of energy and other resources. On the other hand, there are also potential challenges and drawbacks to the development of space habitats. For example, building and maintaining these habitats would likely be incredibly expensive, and the technical challenges of establishing a self-sustaining community in space would be significant. Additionally, there are also potential ethical concerns to consider, such as who would have access to these space habitats and how they would be governed. Overall, the potential impact of space habitats on society and humanity's future in space is difficult to predict, and would depend on a variety of factors. However, it is clear that the development of these habitats could have both positive and negative implications, and careful consideration would need to be given to the potential costs and benefits before moving forward with such an ambitious project. Alright, thank you very much for checking out my video. If you made it all the way to the end, let me know in the comment section. And if you liked today's video, be sure to give it a like, as well as hitting that subscribe button and bell icon. It seriously helps small channels like mine. Thank you, and have a good rest of your week.